So in this video we're going to talk about the different phases of mitosis and then finally cytokinesis, which is just when the cell splits up. That one's pretty easy. So the cell has already prepared to divide. It's even doubled its genetic material. This is the process of where it actually does divide. It's called mitosis, and it's definitely a clone of the cell. So don't think that this is where an egg and sperm come together. This is when one cell is going to make a duplicate copy of itself. And you know that, like, if you were to go to Kinko's and make a duplicate copy of a copy, it sort of fades. And if you were to take that copy and make a copy of that, it fades. And if you were to make a copy of that and make a copy, it starts to fade and fade and fade. It doesn't look like the original. Well, that's what aging is. It's just that you've made so many copies of these cells over and over and over again that the code itself, the genetic material, starts to get a little harder to read. Maybe there's some mistakes in there. And then over, let's say you were to do that Kinko's thing, let's say 10,000 times, and you compared that 10,000th print to the first one, it's not going to look the same. Granted, if you just put the original in and hit 10,000 copies and waited, they'd all look pretty similar. But what I'm talking about is you took that copy and took it out of the machine and then made a copy of the copy and then made a copy of that copy. That is going to start to deteriorate and look the same. And that's what we call aging. But with mitosis, we kind of go through this thing called PMAT. Prophase, metaphase, anaphase, and telophase. Each one of these I gave you a little clue word as to how I think about it. Prophase means prepare the chromosome for cell division. Metaphase means meet. The chromosome material will meet in the middle, and you'll see a picture of that in a second. Anaphase is apart. The cell is going to tear apart. The genetic material is going to move apart from each other. And then finally, telophase is where the cell starts to tear apart and then become two. So prophase is prepare. You could see that now a couple of things are going on. That the material's already been doubled in S phase. So what's happening now is the genetic material is starting to sort of line up. The nucleus is going to start to dissolve soon. We have these other kind of spindles that have come across. These are called spindle fibers and centromeres. Centromeres are going to be the two spots that'll eventually be two new cells. They're almost going to be like poles, and they're going to sort of move everything to each pole. The spindle fibers are just microtubules that are going to attach to those chromosome material and make sure everything just gets organized the way it needs to. Our next phase is going to be metaphase. You'll notice now that the nucleus is completely gone. And what you're seeing here are the spindle fibers have lined up, and they're sort of lassoed onto the chromosome. And if you remember how I told you the attachment site of these two chromosomes is called the centromere? Well, you could see that now the spindle fibers themselves have attached to that centromere. One's on this side, one's on this side. So the genetic material is lined up in the middle. The spindle fibers are on both sides, and eventually what's going to happen is we're going to go into anaphase. Anaphase is where they're being pulled apart. So let me go back one. You can see that the genetic material kind of looks like a little H. They're all lined up in the middle. And then when we go to anaphase, they've now separated into two, and they're still being tugged on by the spindle fiber to the opposite poles of each other, those centroles. You can see this half is going here, and this half is going here. I'm showing you a really simple version because if I were to show you what humans look like in a picture like this, it'd be too confusing because it'd be 46 different things moving around and it would just be too much. So this is just a really simple cell. Eventually, we've gone past the anaphase where they've separated and sort of gone to the two sides, and now we're at telophase where the genetic material is definitely in these things that are going to eventually become the nucleus. And you could also see that the cell is starting to pinch off in the middle. And that pinching off is called a cleavage furrow, and this will become one cell and this will become another cell. The next phase is just called cytokinesis. I'm not going to talk too much about that one. It's just where the cytoplasmic material makes sure that it's all equal on one side to the other. We're going to make sure that those organelles, like for instance, if this cell had 4 mitochondria, 2 will be in this one, 2 will be in this one. It'll also make sure that the Golgis and the rough ER, there's one in each copy before they separate. And these are what they sort of look like in real life. This would be interphase. This is metaphase. See how the chromosomal material is in the middle. Anaphase, they're apart. This would be after cytokinesis. What happens to get us from one step to the next? Remember that phases of G1, S, G2? Are these things called growth factors, and they're external signals that give the cell permission to divide. Now, the things that tell the cell it can divide are a couple things. Density. If there's too many cells nearby, you definitely cannot divide. But if that density decreases, so let's say there's a paper cut or an injury or a break, then definitely we're going to go ahead and start to do mitosis to fill in that gap. Anchoring. The cell has to be attached to something for it to be dividing. If it's not attached to something, let's say it's just floating in liquid, it doesn't grow. Chemicals, there has to be some growth chemicals to say, yes, you can go from one step to the next, and it just is kind of like a speed bump to make sure everything's working correctly. And those speed bumps are called checkpoints. Checkpoints are things that are designed to make sure that the cell can go from one phase to the next one. When these checkpoints are removed, for whatever reason, biologically or chemically or whatever, we can start cranking out cells with no control, and that's what we call cancer. Normally what happens is there is that G1 phase, so the cell is just sitting right over here, happy, and all of a sudden a signal is given to that cell to say, hey, you need to start getting ready to divide. So it'll start to grow and get bigger and hit this checkpoint. If everything in the cell is still good, because this is going to be where it's going to do its first quality control check, it's going to keep going. If there's something wrong or the situation has changed and we can't grow this cell right now, it's going to be ejected and it's going to do this thing called apoptosis. Apoptosis is programmed cell death, and it just basically is when the checkpoint says no, or the cell is bad, or there's something wrong. So this is where the cell is going to program itself to sort of self-destruct and die. Apoptosis. But let's say everything is good. We're going to go to S phase, and we'll have another double check, and we're going to just make sure everything is going well. If we keep going at a S phase, we're going to keep going until our next checkpoint comes, and this is going to be our checkpoint that's going to say, hey, you can go into mitosis. And if this one is there, then we'll kind of go through and just keep this process going and going and going. You might have heard some of these cancer terms before. If you've had somebody with cancer, you might have heard the word P53. P53 is one of these checkpoints, and when they go away, or a couple of these go away, you start having major problems. In humans, we have about 2, maybe 3 checkpoints, so 2 or 3 different P53 sites, little checkpoints. But we've recently discovered in elephants they have 40 different chemicals and checkpoints. And what we're trying to do is see if we can modify those to be in us. Because for elephants, it's very, very, very rare for them to get cancer. Where for humans, it's pretty much inevitable. If you live long enough, you're going to have cancer. You may not die of cancer, you might die of heart attack or whatever, but if you live long enough, you will definitely get cancer. Oh, and then with breast cancer, you've probably heard of BRCA1, BRCA2. BRCA1, BRCA2, or breast cancer gene 1 and breast cancer gene 2 are basically these same checkpoints. If you're missing one of them, you have a higher rate of getting breast cancer, and that's what they're really talking about. There are different types of tumors, and we'll talk about cancer in our next video.